To N4 Learning. I want to talk to you today about a I/O module. This particular I/O module here, it's a 40 input output module, and it's roughly the same size as an ISMA I/O module. Now this is just Modbus, it's not Modbus and BACnet, so it can only do Modbus. And across here I've brought a clip across. Let me bring that across for you. And on power up, you see it will go through a light check. I'll just start that at the beginning. So that's your light check. And then these will start flashing, these universal 1 to 8. Now I've got a temperature sensor already connected in here to universal 1, and you've got your UI1, and then you've got your ground. The RS485 is connected here, your A and the B. I haven't connected the screen, and the power, which is currently 24 volts DC, is connected to these two terminals, this being plus, this being minus. This is an ISMA mix 38 module to the left hand side of this. In fact, I'll show it you all together. Let me just move that one out of the way and bring this one across. So there you have your ISMA mix 38, and then you have your core 40 I/O 40. So you've got your digital outputs here, DO1, DO2 to DO8. These are actually, these at the bottom here, DO1, 2, 3, 4, 5, 6, 7, 8. Then you've got your digital inputs, which are here. And then you've got your universal inputs, which are these front terminals here. And then you've got your universal outputs, which are these back terminals here. These dip switch settings, this is currently set to 9600 baud and address 1, so that's up there for address 1, and that 7 is up for just 9600, but you would use 7, 8 and 9 dip switches to set your baud rate. And this is your end of line resistor if you want to use this. I've currently disconnected that, I'm not using it. You've got a reset and a boot. You can put a small little pin in there to reset that, or to boot it back up again. So what I'm going to do now is I'm going to go to the wire sheet, and we can look further on the wire sheet. You can get further information from bmsparts.co.uk website. I've put a zip file there for the core palette, so I made a palette and zipped it up, so all you need to do is unzip it, and I'll show you that in a bit, how to actually load that. You've got some data sheets here. I'm using not the IP one, I'm just currently testing the RTU, so just Modbus RTU. And you can also, with the IP one, there's a default port there, IP address, but again I'm not using the IP one, I'm used to using the RTU one. And you've got a Bluetooth Android app that you can download. You just go to your Google Play and search for core settings. Let me find that for you. So this is your Google Play core settings, so you can download that, and you can use the Bluetooth to actually change the inputs, set outputs. Everything's there in the app, so if you load that onto your phone, I don't think there's an Apple version at the moment, I think it's only just the Android version, unfortunately, but it works well. Once you've changed this point here, you click on this update down here, and it will update via Bluetooth that point to what you want it to be. So let's go to the Niagara Tridium workplace. So I'm running 4.10, so I need to connect to the controller. File, open station 92.168.1.140. Let's use this Modbus. Oh, let's bring the palette in. I'll show you how to do that. I think I've got it saved on drive C, so browse, drive C, this office, and I should have a palette there. I got. So this is your palette. I'm using Modbus Async, so we can minimize that, and I'm using the multi 40. So let's just take the multi 40, all of it, and drag it into COM1. Let's make sure we set the address in there. Address 1. Right click it and ping it. Looking good. And let's go through some of these points. So BMS timeout 10 seconds. Universal inputs, so we've got mode select. So it's all set to 0 to 10 volts analog. If I right click that, action set. So I can set these to 2 to 10, 0 to 20, 4 to 20 for the milliamps, and there's no resistor required. And then you've got the temperature sensors here. So I know that on universal input 1 I've got a 10K3A1 installed, so let's click on OK there. So NTC 10K301. Read value. So that's my read value, 285, which naturally need to move the decimal point across. Oops. And we'll give it 2 decimal place. No, I'll just give it 1 decimal place. Oh, no, let's see whether it does. It will do 2. Give it 2 decimal places. I'll just change that the same as well. 28.4 degrees. Let's set it up with temperature. We've got minimum value setting, maximum, and we've got offsets. Digital inputs. So you can config views, DI config OD1 reverse, so you can reverse it, and a pulse. So there's your pulse counting. Inputs. universal outputs. Mode select. So you can set it, your universal outputs, to pulse or digi, which is quite good really, because you've got more options. So as well as the outputs that you've got digital, you've got another 8 there if you want them. Let me bring that screen across. So you've got them normal 8 there, and then if you want you can have them 8. So you can have 16 outputs compared to a ISMA which has got 12 outputs only. 7 analog outputs but 12 digital outputs. Okay. Status. Output default. Min max, offset value, and pulse counting. I think I need to read the manual of this before I start doing videos, but I just wanted to show you this module. And I need to put it through its tests. Digital output mode, action set. Status. Default output. .04 version. I've done the watchdog. Right then. So let's move the camera in front of it and let's see what it does. So we have this camera in front of the I/O unit. That power light's really bright. So now what we're going to do is operate some outputs first. Let's just put a Boolean writable to it. Set that to a true. Write it in there. So that's flashing. So let's now set that mode for that one. Action set to a digi in direct. Let's break that. Let's set the mode to a digi out. Digi out direct. Yeah. So universal output 1 is now a digital output. And if we set it back to 0 to 10 output, I'm going to give it 5 volts. It's now flashing because it's an analog output. Okay, then what else should we try? Let's go to digital outputs. Status. Views wire sheet. I heard that click. So digital inputs are just going to be digital inputs, nothing special about them. Universal inputs, we've already looked at that, and the read value at the moment for that 28.8, which is a temperature in here. That's not flashing anymore now. These don't have anything connected to them. So I presume the flashing means that faulty, no connections. Which is a good indicator. You can see straight away if you've got a faulty unit that's not connected. Faulty sensor. Which is a good idea. I like it where each individual terminal's got their own ground. So you're not coming up the ground at all. So that's another pro for this. The only con is that it's not backnet, but not for me because I don't use backnet anyway. I always prefer using Modbus because it uses less system resources than what backnet does. Yeah, I like that. Right, I'm going to have a carry on playing with it, and if I find anything new, I'll let you know. I decided to take a look at the manual. I thought it would be nice to just put some of this information in. So we've got parity none, 1 stop bit and 8 data bits. We can't change that. So if you've got some even parity meters on your Modbus port, then you either got to change them to none, or you've got to use another Modbus port. You can't change this parity. It's set at none. And normally the meters and sometimes set it even, but you may be an option where you can change. If you need to use that COM port, you may be able to change the meters to none, but it's fixed at none. The dip switch settings, so the end of line resistor, which you can use if need be. I normally don't use them. See what else there is. Right, we've got some dip switch settings here. Adjacent we only go up to 115,200 kilobytes per second. I don't know what device will do 230,400 kilobytes per second. But for Jace itself, for Niagara in my world, that's the highest that we can actually get to. So, but apparently this will go faster. So these are your dip switch settings. I've currently got it on as 9600 baud rate. So 1 on, 7 on, and 8 and 9 off. And I've got it as address 1 with the 1 on there, as you can see. And then you can just set your addresses. So if you want it to be address 2, that one, 3, so it's a 2 and a 1. There's a 3 there as well. Sorry, so that's 4. So if we wanted address 10, for example, we would put 4 on, 5, 6 on. So sorry, number 2 on and number 4 on. So that's 1. That is actually 2, but that's 4, that's 8, 16, 32, 64, and so on. No 64, because that's used for the baud rate. So 1, 2, 4, 8, 16, 32, and out of them combinations you can make it. So if we looked at 10, we've got 8 on, which is dip switch 4, and 2 on, so 8 plus 2 is 10. Let's have a look at some more info in the manual. So the rest of the manual is just the hex and decimal codes, but this is just showing you the digital input wiring that you would do for an input, for an output, resistor input, 4 to 20 milliamp. Notice there's no resistor, so that will be built in once you've set it, and the 0 or to 10 or 2 to 10 inputs. The flashing lights that you can see in the video down here, it says here blinks on times 3 times in 50 milliseconds intervals, then pauses for 800 milliseconds, always on the inputs 0 to 10, 2 to 10, 4 to 20, or 4 to 0 to 20 or 4 to 20 milliamps. And that's just all normal as well. Alright, well I think that's it. I can't think there's anything else. Like I said, I'm going to put this through its paces, and I'll let you know how we're going. Bye, thank you for watching.